A perfect square trinomial is a trinomial that you can take the square root of and get a binomial. So it's a binomial times itself, gives you that perfect square trinomial. For example, when you have something like, when you have an actual square, and this is, the side length is x, then yeah, the base and the height are both x, so the area is x squared. So when you have, if we were to FOIL something out using the box method, if you had x plus 3, same base and height, so you have a perfect square, then you end up getting x squared plus 6x plus 9. This right here is a perfect square trinomial because it can be factored as x plus 3 quantity squared. Perfect square trinomials are really just a pattern that they factor the same way each time. So you have a perfect square here, a perfect square there. What is the square root of 16? It's 4. What's the square root of 25? It's 5. And so the middle term should be 4 times 5 times the pattern goes 2. Okay, so 4 times 5 times 2, is that indeed the middle term? 20 times 2 is 40. So yes, this is a perfect square trinomial, and it factors to be 4 and 4, x and x, 5 and 5. To get a positive, the signs are both the same. If the middle term is positive, that means the signs are both positive. It's supposed to be a shortcut. You can factor normally the way that you would just any other method, but this is supposed to show you that there's a pattern that we follow here. I'm going to add a problem in that's difference of perfect squares just because I messed up with that. So for example, you could have 5x squared minus 36. Sorry, it's supposed to be 25x squared minus 36. Difference of perfect squares factors into the square root of 25x squared, so 5x and 5x. The square root of 36. 1 is plus, 1 is minus, and that's the difference of perfect squares. Just factoring regular quadratic expressions, always make sure to take out the common factor. Here we have 2 is common, and so is m. So we're basically undistributing these. You're left with m squared minus 5m plus 6. And then you can factor this one normally. So the 2m remains, but this goes into the 2 parentheses, m and m. Two numbers that multiply to give me 6 and add or subtract to give me 5. So you can look at all your factors of 6 over here if you'd like. 2 and 3 work. Well, 1 and 6 also work, so it's important to check your signs for this. A plus, to get a positive 6 when you're multiplying means they both have to be the same sign. And the sign right here is what they both are. So they are both negative, so it has to be minus 2 minus 3. And that's completely factored for this expression. Factoring quadratic expressions in quadratic form is basically you have a quadratic which is in the form of ax squared plus bx plus c. And you have x squared and then an x to the 1 and then a term with no x. Quadratic form is where maybe it's not 2 and 1. We'll put the little exponent for 1 here. Maybe it's not 2 and then 1, but it's in that same pattern. So it's like 4 and then 2. Or it could be 6 here and then 3. Whatever it is, this is twice as much as that. And there's no term out here. There's no variable on the third term. Okay, so this is quadratic form. We factor it in the exact same way, but instead of x and x, we do x squared and x squared. And then two numbers that multiply to give me 60 and add or subtract to give me 16. I think it's pretty obvious what we're looking at here. 6 and 10. Both signs are the same to get a positive 60. And since this is negative, both signs are going to be negative. Once you've factored quadratic form, always make sure to check if there are any difference of perfect squares, if you can go further into 2 more binomials. 6 is not a perfect square, 10 is not a perfect square, so we can't go further. Sum of cubes and difference of cubes is really just in the same, it's just kind of this form that it always takes, and you just kind of have to memorize which form it takes, just because this is the way it does. It happens every time. Somebody figured it out somewhere, and so they made it easier for us. So what happens here is if you have perfect cube and a perfect cube, and it can be the sum or the difference of those perfect cubes, then we can factor it as follows. So we would say that if this term is a cubed, then what is a? Well, it is the cubed root of this term, so that's 5x. And then the cubed root of 1 is 1, and then we drop our sign. Okay, so you see that it remains. So the first term in the second parentheses is the first term squared, so 25x squared. The last term, as you can see, is b squared, the second term squared, so 1. And then inside we have minus ab, so 5x times 1, which is 5x. And then I'll drop down that sign. There's always going to be 1 minus, 2 plus. So if the minus is in front, then there are 2 plus in here. If the plus is in front, then the minus is sandwiched in between. Now you're completely done factoring this. If this were an actual equation and you had to solve, this right here is unfactorable. You cannot factor it. You have to solve this by quadratic formula. When there are 4 terms, we like to factor by grouping. So here I have these 4. I'm going to not take a look at the second 2, and I'm just going to look at the first. And that's going to be my group. What can I take out of the first? Just common factor. I can take out a 2 and an x squared. And I'm left with 6x plus 5. Now I look at the next piece. This is my next group. 18x minus 15. Okay, so there's a negative in front. Don't lose that negative. And then what can I take out of here? 3. So if I'm taking out a negative 3 times positive 6x gives me 18x. And then negative 3 times positive 5 would give me that negative 15. And now I see that I have a common factor. That literally there are 2 terms here. You like have this term minus this one, and 6x plus 5 is actually in common, so I can take that out, take out that common factor. So you have 6x plus 5, you write it 1 time, times what we have left, which is 2x squared minus 3. And that's how we factor by grouping. Finally, let's solve by taking square roots. So get that x squared by itself. Since you don't have any x terms, we don't need a factor. 6x squared is equal to negative 27. Divide both sides by 6. X squared equals negative. We can reduce this. Both are reducible by 3. And we get negative 9 over 2. Then we square root both sides to get rid of that squared. And we have x equals plus or minus. Do not forget your plus or minus. Anytime you take the square root in the middle of an equation, you need to write plus or minus. And we have square root negative 9 over 2. This, we need to rationalize the denominator because the square root is dipping into the denominator as well. So we'll have x equals plus or minus square root -9 over square root 2. The negative can go either way. I just put it on top because it's easier. X equals plus or minus, hey, the square root of -9 is actually 3i, which we learned earlier this week. 3i over root 2 times by root 2 over root 2 in order to get rid of the root in the denominator. And I'm running out of room here. X is equal to plus or minus 3i root 2 over 2. And that's how we simplify that.